Welcome, everyone. My name is Randal Koene. I'm the founder of the Carboncopies Foundation. This is a relatively brief 10-minute introduction to the workshop. As the title says, the discussion today will be focusing on functionalizing models using collected brain data, specifically data that's obtained largely from a single specimen, such as the data that was in the EM dataset made available by Genelia Research. The concept of ground truthing, learning more about information processing in the neural tissue of model organisms from C. elegans and Drosophila to mouse and human, and how this all ties into the problem of system identification when building a model and validating that model. And the role that artificial data can play, not as a source of biological ground truth, but as a substitute that can aid in the development of methods that can be put to use when working with real data. So why this set of subtopics? In short, we could abbreviate the problem of brain emulation as follows. Understanding goals and stating the problem in a useful way. Collecting data that should make solving the problem and achieving goals possible. Using data to solve the problem by constraining and initializing a model, and by parameterizing and validating the model to ensure that goal-directed success criteria are met. Certainly, there are many challenges remaining in step 2 in the data collection. Some parts of that, like large-scale dynamic recording, even in deep tissue, or making a full inventory of molecular processes, are still particularly thorny technical issues. Nevertheless, published work in recent years and ongoing projects demonstrate that the technical challenges of data collection are receiving significant attention. And in some areas, great strides have been made, like collecting, post-processing, and annotating morphological data via electron microscopy and other means. It's always tempting to continue to focus on the part of the problem that's been developing at a rapid pace, because that's where the field is well developed and where well understood protocols can continue to be applied and rapidly produce more output to publish. But if you take a step back and look at the overall problem in terms of the 3 steps outlined here, a critical observer might be tempted to make accusations of bike shedding if the focus of discussion is perpetually step 2. Bike shedding is a colloquial term for a phenomenon where if you put a bunch of engineers together in a room to discuss a difficult problem, you might find that 80% of the session was spent discussing which color to paint the bike shed, simply because that was an easier, more familiar, and more comfortable problem to address. So this workshop is primarily about step 3, with necessary references back to addressing step 1. It's my personal belief that these 2 steps are the ones where the biggest scientific challenges are presently hiding. I also believe that progress on steps 1 and 3 will ultimately benefit step 2, because better understanding topics such as success criteria, validation metrics, neural code constraints, and scale separation, all of which are important to rigorous system identification, will point out important requirements in data collection. As we get started, I should also point out that we've planned a series of 2 workshops under the heading Brain Emulation Challenge for the first half of 2025. This workshop here is meant to clarify goals, challenges, and perspectives regarding paths to solutions and has more of a theoretical slant. Our second workshop is intended to be a hybrid event, including in-person participation and an opportunity to play with tools under development hands-on. Of course, we have to understand where we're at. What is the current state of the art in brain emulation? There are a lot of different examples we could discuss here. For example, we could discuss work on a hippocampal neuroprosthetic that was a major topic at Carboncopies workshops for a few years ago, and of course during my time at the startup kernel. Or we could discuss various digital twin projects around the world that focus on creating avatars using information that treats a person as a black box problem. Or we could discuss ideas around functional emulation using fMRI data and machine learning. Instead of going broad, we decided to go deep because our aims at the Carboncopies Foundation require it. So we will set the stage mainly with accomplishments and limitations in approaches using morphological and connectome data and attempts to faithfully produce high-fidelity models initialized and constrained by that data. I once made a very informal survey of friends in the know, including domain experts at Genelia, to see if they thought that there might be enough data in the fruit fly data sets collected today to produce near behaviorally complete emulations of fruit fly based on that data, if only we were able to complement that data with sufficient understanding. In other words, might one theoretically produce a satisfying emulation of a fruit fly given the data already collected? To my mild surprise, the majority consensus was that yes, that might be possible. Admittedly, there's probably a selection effect there based on whom I asked. Still, this again raises the possibility that our main challenges lie in steps 1 and 3 of the preceding slide and not in the area of data collection. After an introduction of the state of the art, the second topic today will be to take a closer look at the problem. We wanted to consider goals in brain emulation and what does it mean to achieve a successful emulation, to carry out a process of reverse engineering by any means. Measuring success and performance implies that there needs to be a way to verify and validate a model. In an ideal world, you have a fully understood or fully known ground truth with which to compare a model, a rigorous set of criteria and methods of validation. Unfortunately, that's very hard to come by. Hopefully, we'll have a good discussion about at least the known unknowns and what insights do we have about current limitations when it comes to neural circuit emulation or neuroprosthesis derived from either recorded dynamic data or through functionalization of morphological and connectome data. That leads into the third topic for the day. We'd like to discuss the utility, proper application, as well as the limitations and risks of using artificial data as a supplement in an effort to explore system identification. And there are successful case studies in adjacent fields that can serve as examples. Finally, we'll be introducing our forthcoming brain emulation challenge. What are its goals? What's the protocol, the platform, and what are the opportunities to participate in the challenge? We've been working on an open source, open science platform and protocol that is meant to explore validatable methods for system identification, functionalization, and reverse engineering, as well as to explore hierarchies of scale separation established by system constraints and neural coding constraints. We're calling the approach generative meta-analysis. We'll present the overall protocol and what the first open challenges will look like upon launch and how you can participate. We're hoping to build a community around this problem domain and towards a rigorous advancement, not just to test approaches and algorithms, but also to discover overlapping ideas and interests and opportunities for new partnerships. So we tried not to cram the agenda for today so that every speaker will have ample time and be able to emphasize parts of the conversation that we care about the most. And there's a break in the middle of the workshop. Each talk is flanked by time for Q&A and brainstorming. To get us started with the state of the art, Dr. Philip Xu and Jan Lapalainen will each give a talk about their respective approaches to functionalization of models based on Drosophila EM data from Genelia research, as published in their excellent Nature papers. Then I don't think anybody needs me to talk or write about data collection. There's already an ample supply of competing research groups, entire institutions, and now also startups competing to ramp up and continue to improve that. So in my talk, I'll focus on what I think are the most underserved parts of the domain. One of those is theoretical foundations, making our way towards an understanding of the problem or problems we're trying to solve on a par with the sort of understanding that we see in established fields like physics, chemistry, and cosmology. And the other one is on the output side, getting to emulation. In other words, being careful and systematic about the process of system identification, solving inverse problems, constraining models, and functionalizing them. So one step backwards to foundations, one step forwards to outcomes. By the way, I'm convinced that improving our understanding of those two will in turn cycle back to data collection by providing greater confidence about the data that's needed and how to use it. As we know, in established subfields of physics, biology, cosmology, etc., problems are generally carefully and concretely described, leading to well-formulated studies. We'd love it if our interactions at this workshop can help the nascent domains of brain emulation in its effort to become similarly rigorous in terms of goal specification and beyond. So after the break, Professor Konrad Korting will give a talk that I'm sure will give us clarity and insights about ground truthing, reverse engineering, and related matters. And then we'll hear from Professor Razvan Marinescu about his computational explorations and avenues as applied to brain data. We round out the day with the introduction to the work we've been doing in our research group to build an open science platform for generative meta-analysis and its application to competitive challenges. Finally, we'll have some time for open discussion. There will be opportunity to further discuss the topics of the day, which will hopefully lead to a useful summary of insights. I hope that all participants will come away from the workshop with an appreciation of the current state of the art and of the possibilities and challenges in brain emulation, to understand the current limitations and why those limitations exist, perhaps even directions that contain a promise of breakthroughs. I hope that we can also learn about innovation and improvement cycles, progress accelerators, and careful and appropriate application of artificial data. I hope that I'll be able to familiarize you with the idea behind our brain emulation challenge, its purpose and collaborative approach, that will entice constructive criticism and helpful feedback, and that participants will see opportunities to contribute from participating in challenges to supporting growth of the initiative. After the workshop, we'll be going through the recording of the event, and we'll be checking in with speakers about the recording of their contribution before we make a recording available to the general public. We'll compile a workshop report, which we will publish in some as yet unspecified form, but will certainly be available through our website. And of course, we'll be preparing for the second workshop in this series, the hybrid event with in-person participation on location, either in the beautiful Sierras of California or potentially at the University of California at Santa Cruz, if that's possible. That workshop is currently slated to take place either in May or June, when we can give participants a chance to explore generative meta-analysis hands-on. Let me also mention that we're opening a forum on Discord for both workshops in the series. The forum is going to give room for additional Q&A, ongoing discussion, feedback as we prepare the report, and more. I hope you'll all join the forum. Thank you all for joining us today.